Hello everyone, welcome to our video about the basic analytical chemistry. On this video presentation, we are going to discuss about the determination of sodium hydroxide in detergents using volumetric technique.
What is volumetric titration? Volumetric titration is a chemical procedure that uses titration to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another. In this technique, a standard solution of known concentration is titrated against portions of an unknown concentration until the reaction is complete. The volumes are measured to determine the amount of unknown chemical in the specific volume of solution.
The purpose is to determine the volumes of sodium hydroxide in detergents using volumetric technique.
The basic components of titration typically comprises a research stand, conical flask, pipette, burette clamp, and a white tile to observe color changes. The titrant is the known solution that is added to the unknown solution, followed by the analyte, which is the unknown solution being tested. The indicator is also a component of titration.
What is the example of titration? There are many types of titration with each example of indicator that can be used. For example, strong acid to strong base, which its indicator are methyl orange and phenolphthalein. Next is strong acid to weak base, which its indicator are methyl orange and bromothymol blue. And then strong base to weak acid, which its indicator is phenolphthalein. Lastly, weak acid to weak base with no indicator. Next, let's proceed with the step of titration. Firstly, pipette measure acid or base solution into a clean conical flask, and then add a few drops of indicator to the conical flask. Next, fill the burette with the standardized acid or base solution. After that, slowly add the solution from the burette into the conical flask while swirling the flask gently to mix the content. Lastly, continue adding the solution slowly, swirling it gently until the color in the conical flask change. Let's proceed with the theory for the experiment to determine sodium hydroxide in detergent. The volumetric technique used in this experiment is titration, which is strong acid to strong base titration. This method relies on the neutralization reaction between a known volume of base solution and a known concentration of standard acid solution. Solutions used in this experiment are hydrochloric acid, which is the acid solution in the burette, while sodium hydroxide, which is the base solution in the conical flask. Indicator that is used in this experiment is phenolphthalein, where the color in the conical flask changed from colorless to faint pink color. This is due neutralization between sodium hydroxide and hydrochloric acid changed to sodium chloride and water. At the end of experiment, the volume of acid required to neutralize sodium hydroxide is used to calculate the concentration of sodium hydroxide in the detergent sample.
So let us go for methodology. The purpose of this methodology is to determine the sodium hydroxide in detergents using volumetric technique, which is titration technique. The material area agents that we needed is detergent sample, distilled water, phenolphthalein indicator, and hydrogen chloride solution. The apparatus that we needed is analytical balance, burette, pipette, stirring rod, funnels, beaker, and Erlenmeyer flask. The procedure. First, we need to prepare the sample. The first step is accurately weigh approximately 1 gram of the detergent sample using an analytical balance and record the exact weight. Then, dissolve the weighed detergent sample in about 100 ml of distilled water in a beaker. Stir the solution until the detergent is completely dissolved. Then we can proceed with our titration procedure. First, we need to rinse the burette with the standard hydrochloric acid solution. Fill the burette with the standard HCl solution and ensure there are no air bubbles by gently tap in the burette or the tip. Secondly, use a pipette to transfer 10 ml of the detergent solution from the beaker into a 250 ml Erlenmeyer flask. The third step is add 2 to 3 drops of phenolphthalein indicator to the detergent solution in the Erlenmeyer flask, the solution will turn pink if sodium hydroxide is present. The fourth step is begin the titration by slowly adding the HCl solution from the burette to the detergent solution while continuously swirling the flask. Continue adding this acid until the pink color of the solution just disappeared, indicating the endpoint of the titration. Then, the last step, we can record the volume of HCl solution used to reach the endpoint.
Determination of sodium hydroxide in detergent by titration is applied in a few ways, including quality control, effective cleaning, safety and environmental impact, and cost optimization. For quality control, manufacturers need to ensure that the sodium hydroxide concentration in detergents meets specific standards. The accurate determination helps maintain consistent product quality. For effective cleaning, sodium hydroxide is an alkaline compound that contributes to the cleaning power of detergents. Knowing its concentration ensures effective stain removal and grease dissolving. In terms of safety and environmental impact, excessive sodium hydroxide can harm fabrics, irritate the skin, and damage surfaces. The proper formulation of detergent prevents these issues. Environmentally, excess sodium hydroxide in wastewater can affect aquatic systems. Monitoring this helps prevent pollution. Lastly, cost optimization. The precise sodium hydroxide determination allows manufacturers to optimize raw material usage and therefore reducing the cost of production.
There are plenty of precaution steps that should be considered. First, we need to control the titrant flow. Near the endpoint, we need to add the titrant drop by drop to avoid overshooting the equivalent point that can cause error. Second, remove the air bubbles trapped in the burette by gently tapping them and letting a small amount of titrant flow to the teeth. Third, place a piece of white paper or a white tile at the bottom of the conical flask to better observe color change of the indicator. Lastly, the titration flask should be shaken continuously to ensure the solutions mix properly and react completely. Following these steps will ensure that the titration results are accurate and consistent while also preserving lab safety. To conclude, the volumetric determination of NaOH in detergent is a reliable and accurate method when conducted properly. Key factors include the careful preparation and dissolution of the sample, accurate standardization of the titrant, appropriate choice of indicator, and meticulous execution of the titration procedure. By adhering to these steps, the concentration of NaOH in detergent can be determined with high precision, which is essential for quality control and regulatory compliance in detergent manufacturing.